Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by KUKA. Discover how to program KUKA robots directly from your CNC controls. No robot programmer required. This webinar will showcase practical examples of plug-and-play communication between your machine tool and robot, enabling direct robot control through your existing CNC interface. Learn how to bridge the gap between robot integration and machine tool automation by utilizing your existing in-house resources. Our presenters are Ron Bergman, Key Technology Manager for Machine Tool Automation, and Philip Peloso, Business Development Manager for Machine Tool Automation at KUKA. Ron is the Key Technology Manager for Machine Tool Automation at KUKA Robotics Corporation. With 30 years of experience in robotic and CNC controls, Ron brings a unique perspective to help customers automate their machine tool processes. He also has extensive experience with various robotic applications that require a high degree of path and/or position performance, ranging from ultra-safe entertainment to tight tolerance aerospace processes. Philip is the Business Development Manager for Machine Tool Automation at KUKA Robotics Corporation. Having worked in the field of industrial robotics and automation for over 30 years, Philip brings a mix of knowledge, experience, and passion to the role. Philip enjoys working collaboratively with all parties to drive solutions forward and ensure the goals of the customer are met. You can submit questions at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. There are also some polls throughout the webinar, so keep an eye out for those. And finally, I wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with all of that, let's get the presentation started.
Fantastic. Julia, thank you very much for that introduction. And on behalf of my counterpart, Ron, and myself, and the entire KUKA Robotics organization, thank you for attending today's webinar. Our goal is to provide you with some ideas and things to think about before you add robotic automation to your machine tool. And whether it's your first time automating or your 21st time. But before we dive into today's topic, a brief history of KUKA Robotics. KUKA was founded in 1898, making the company 127 years old. That's a lot of candles on a birthday cake. The name KUKA comes from the last names of the two founders, Keller and Nappich, and they were based in Augsburg, Germany. So the name KUKA stands for Keller und Nappich Augsburg. KUKA began as a supplier of acetylene gas used for welding and cutting, went on to manufacture industrial containers and welding technologies, and then eventually robots and equipment for industrial automation. Some interesting firsts for KUKA as it pertains to robotics. KUKA developed the world's first.
Hey, Phil, hold on for 1 sec. There's a note about no audio feed.
Are we having issues with audio?
Julia?
I can hear you guys just fine. It might be something on Tom's end, but if anybody else is having audio issues, please let us know. But I'm hearing everything just fine.
All right. What do you say we keep rolling? Maybe it's just Tom. Hopefully you get your audio.
Yeah, somebody else said they can hear. So let's keep rolling for now.
Perfect. Okay. Thanks for teeing that up. So interesting first. KUKA was developed the first electromechanical robot in 1973. That's over 50 years ago. And 20 years ago, 21 years ago, in 2004, it released the world's first collaborative robot. And we continue to develop many new products involving robotics. Needless to say, robotics technology runs deep in KUKA's history. So when developing robotic solutions for machine tending, several factors need to be considered when selecting the proper arm. You can see here KUKA has a wide variety of robots in our portfolio. But when you're selecting the right robot, one of the factors is the robot reach. Robot reach is a measurement of distance giving, in the metric system, and it can be shown in millimeters, like 600 or 760 millimeters. or conversely in fractions of a meter, like 1.6 or 2.1 meters, and so forth. So another consideration for selecting the robot arm is the rated payload for the robot. And that's measured, that's a measurement of the maximum weight a robot can support. This also uses the metric system as its unit of measure, and it's provided in kilograms. Robot payloads range from just a few kilograms way up to 1,000 kilograms and beyond. The payload rating for the robot must take into account not just the parts, the weight of the parts that are being handled, but also the tooling that's handling the parts, as well as the mass moment of the combined load when the robot's in motion. So a lot of things to consider there, a lot of things to be aware of. Sometimes robots are specified or purchased without considering all of the aspects of tooling, part, mass moment. And then other things to consider and to be aware of is the robot accuracy and repeatability. A simplified way to think of these, they're kind of interrelated topics, is to think of accuracy as a measurement of how closely a robot moves to the desired position in 3D space. Whereas repeatability is the ability of the robot to consistently reach the same position time after time. Most industrial and collaborative robots have accuracy and repeatability ratings measured in fractions of a millimeter. And then lastly, another factor to consider when selecting a robot is the need to work fenceless. This brings up the topic of collaborative robots or industrial robots that are equipped with safety equipment, tooling, and control systems that allows them to work side by side with their human counterparts. We'll see a couple of examples of collaborative robots and collaborative robot applications later in the webinar. In addition to our wide portfolio of arms, auxiliary equipment can also be used to give robots additional reach and flexibility to reorient the parts that are being worked on, as well as to transfer and move the robot from a stationary place along a linear rail. So this equipment comes in the form of, like I said, linear rails, rotational positioners. Examples of this equipment can be seen throughout today's webinar. You'll see a couple of videos where we show how this auxiliary equipment is used, and it'll give you a sense of how this equipment helps expand the functionality of the base robot arm when working with machine tools. Another technology that has really been coming into its own over the past several years is mobility. When it comes to mobility, there are a myriad of configurations available in the market today. Mobile solutions from KUKA offer various size and payloads to choose from, as well as variable drive and navigation systems. Moreover, the addition of industrial and collaborative robots riding on top of these mobile platforms opens up additional use cases to expand the reach and flexibility of automation in the machine shop. When if you have a chance to visit KUKA at Automate this coming week, you'll see some of these mobile units in use at our booth. So this brings us to our first poll question for the webinar. I'll give this a little bit of time for everyone to answer. So do you currently have robotic automation in your facility? You know, it could be 10 days or 10 years old. We're just trying to get a sense of, you know, how many people on today's call currently have robots in their facility. All right, so we'll get moving along here. Continue to answer that poll. It should still be active for a while. So let's start the discussion around steps to consider before you even get your machine tool, with the question of your readiness. You know, is your facility ready for automation as it applies to your employees? A good place to start is through assessing the current skills of your skilled labor, your trades, your engineering team. Do they have the experience working with advanced machinery like robots? This includes jogging and programming, troubleshooting, repairing electrical equipment, repairing or replacing mechanical tooling. This may uncover, a bit of a skills gap that could be solved with training your existing employees or hiring new employees that have the needs, have the skills that you need. And when it comes to training, there is no shortage of funds and programs available at the local, state, and federal levels to get your employees trained up to the demands of advanced automation and robotics. And then depending on your needs, training programs are offered by local community colleges, as well as through robot OEMs like KUKA. Several or the majority of robot manufacturers will have colleges and training facilities integrated to their headquarters. And so as you look at opportunities for automating your machine tool, it's important to understand not only the total cost of the equipment, but the impact that automation has on your operations and whether it's even appropriate to look at automation. If your parts are large and complex with very long machining times, or the parts have low volumes, and you don't have families of parts that can share the use of the automation equipment, adding automation equipment probably won't be a wise decision. If you're not utilizing your automation at a high level, you're going to, have a lot of downtime, and that's costing you money. If, however, you have parts with high volumes, or you have families of parts that are generally similar in shape and configuration, and your machine cycle time aligns well with having a robot and automation feed product, then automating might be right for you. So if it's your first time automating, my recommendations is to start off simple, right? We want to get the simple wins. Look for an easy first win, automating parts that are relatively simple to machine, feed, and handle, both on the robot side as well as for the operators. Just an overall easy part to process. If you take this approach, you may find there's a standard solution in the market that can be readily tailored to your needs. Standard solutions tend to be quicker in terms of delivery of the equipment to your plant. They're cost competitive, and they often have value-added software and hardware features that have been developed and honed over several years and several iterations by the automation supplier. A major part of being successful with your automation is to involve your team, the team that will support and maintain the equipment once it's on your floor. And then once you have success in automating these easier applications, you've got your team trained up, you may want to venture into some more complex applications. I show here 3D bin picking as an example, but truly you want to make sure that the justification behind more complex automation warrants the investment. All right, so you're moving along in your journey into automating your machine tool, and generally understand the financial commitment it will entail. Next, have you considered other ways to maximize the profitability from your automation? Can you put the robot to use on tasks other than loading and unloading the machine tool? Can the robot perform a deburring operation? Can it drill out simple holes or face mill a non-critical feature? Can it do inspection? Can it package the parts? Anything you can do to maximize the use of the robot will help justify the cost of the automation equipment. And so we're showing here kind of an example of, having robots do more than just loading and unloading parts. You can see this particular operation has the robot doing, again, non-critical machining, doing some face milling, doing some material handling, as you see here, doing some tool changeovers. This is actually a sneak peek into KUKA's manufacturing facility. This is how we machine castings on some of our arms, some of our larger arms. Okay, so this brings us to poll question number 2. And the question is, for those in today's audience, are you intending to add robotic automation to your machining operations, say in the next 6 to 12 months? Where I know there's a lot going on in our world today, but the time to automate, the answer is always now is always the right time to automate, regardless of what's happening geopolitically, globally. We applying automation and robotics can definitely enhance your bottom line, and let robots do what they do best and let humans do what they do best. So this question is around the general audience looking to automate. All right, so now let's go over a few ideas to help reduce the risk of your automation project as it applies to selecting the right automation partner. As with many things, it's good with taking a team approach. Use an internal team to research the companies that can deliver a project based around your needs. Consider your potential automation supplier's technical bench strength, their expertise, experience in working on similar projects, where they're located geographically, their ability to support your project remotely if they are located, if they're a few hours away. Do they have the ability to remotely support you? And does your organization allow for remote support into your equipment? Another great idea is really to work with your robot OEM. Rely on KUKA to help recommend an automation supplier. KUKA has partner programs that can really help you narrow the field and ensure you're aligned with the correct automation partner. You want to make sure that you bring the right project to the right automation company. If the project's $200,000, give or take, and a large integrator that typically works on projects in the $3 million, $4 million level, it might not be a good match. And consequently, if you're looking, at a multi-robot project with several machining operations, part transfers, inspection stations, pack out, it can easily overwhelm a smaller company. You should also look for advice from your network in the industry. Find out who has had success with companies you're researching, and learn from their story. All right, so now you have specifications for your project. Remember, start with the simple project, something that's going to keep your machine tool turning and your robots moving. You have a list of potential automation partners, and so here are some next steps to take. My first recommendation is to visit the automation companies that you're investigating. Visit their facility. This will give you a chance to tour their operations, meet their teams, get a chance to see how they operate, starting from the reception desk, extending out to the plant floor, and everything in between. Are they well organized? Do they have a good process flow from front to back? Do they have a shop full of equipment, or is it waiting for the next project to show up? I think you'll gain a lot of insight with in-person visits. Another visit that will benefit you is to take a tour of a facility that's running a system from your potential automation partner. This will allow you to see firsthand what their equipment looks like, how it operates, how the people at that facility interface with it, and generally what their feedback of the equipment is. This might not be the easiest thing to get set up, but oftentimes an automation company will work to get you into another end customer so you can witness firsthand what their equipment looks like and how it's being received by the other customer. And so now that you've identified 2 or 3 companies that check the boxes on your requirements, you've assessed their facilities, you've seen their equipment in action, and provided them with some the same specifications and what you expect from your automation project. You request a few quotes and make sure you're comparing apples to apples. Make sure that the customer, the automation company, addresses your needs around production requirements, ease of use, delivery, support, warranty. Make sure you have at least everybody on the same playing field when they're quoting. And so that concludes my portion of the webinar. I hope it was insightful and informative. If you'd like to meet me in person and talk through your automation project, love to meet you at Automate next week at our booth downtown Detroit. But I'm going to pass the mic to my counterpart, Ron Bergman.
Thanks, Phil. Appreciate that. Welcome, everybody, and thanks for your time today. So simplifying your machine tool automation. Just like people communicating, if you're not talking the same language, your machine tool automation and your machine tool itself will not communicate. So most suppliers have many different options for both safety interfaces and communication protocol options to exchange data between the automation and the NC machine itself. Understand the cost and lead time for these options is critical. Simple digital I/O interfaces can be the least costly. And some of the open protocols like Ethercat, Ethernet IP can be a little more costly, but depending on your needs, may be needed. So you want to communicate your short-term, long-term production needs. How many parts are you producing? What type of parts do you have? You have family of parts. Including your future production needs can help lower your overall cost. Typically, grippers are designed to handle similar parts, but sometimes simple modifications to the grippers could allow them to handle different families of parts, but also parts that are quite different. Or you can have tool changers, you can have grippers that can have multiple fingers. So knowing that up front and supplying that information to your automation supplier could, in the long term, actually reduce your costs and less headaches. Here's an example of a couple of grippers that would load raw materials, sometimes different size parts. Sometimes it could be finished parts, raw material. There's a gripper shown here that's actually servo controlled, so it can handle a variety of sizes of parts. That particular gripper there obviously is handling a round part. The other side of the gripper will handle the round part that's finished. So again, quite a variety of different gripper options available, depending on what your part looks like. But again, the more information you have on what you're doing today and in the future will be important for your solution. You see the same gripper there can handle different widths of parts. So standard, Phil touched on this a little bit, standard system versus custom solution. If possible, you definitely want to take advantage of a standard solution when it fits your needs. Obviously, if it doesn't fit your need, a custom solution may be required. A lot of automation solutions could have the exact same functions, but the cost can be very different. Bit funny pictures here, both can move material around, but the truck on the left is obviously a lot cheaper than that custom one on the right. Here's a good example of a standard solution that was retrofitted with a machine tool. Somewhere between 80 and 90% of this automation was standard, and then 10-20% was added, maybe to adapt the gripper to handle the parts. Maybe the custom solution might be to add different trays for part handling, depending on what your part needs are. But the majority of it was pre-engineered, ready to go. So lower cost, lower lead time, lower risk. Here's an example of a highly customized solution. So definitely a standard solution would not fit the needs with this application. The robot is loading, unloading castings into a machine tool. And for this particular process, machine tool had quite a long cycle time. So the robot was also used to handle different processes, deburring, drilling, riveting, threading are some examples. So while the machine tool's making you money, the robot's also making you money. So if there's not tight tolerance on some of the features, the robot definitely could be used. You can see a tapping process there, for example, machining. You definitely will not have the same performance as a machine tool, but for some features of a part, it's not needed. It definitely improve your return on investment. One thing to consider is, what are the options available for feeding your parts? Sometimes, just a simple mechanical solution is the best solution. Really depends on the type of parts you're handling, the complexity, the variety of parts. Could be bowl feeders, could be trays, could be conveyor systems. On the high end, maybe it's 3D bin picking, for example. So the question is really, how much flexibility do you need in your parts feeder? More complex and generally the higher cost. Here's a good example of a 3D vision system that can pick up parts out of an unorganized bin. So certainly if you have parts that are complex and maybe you're changing parts quite often, 3D bin picking can be an advantage. AI software has really improved some of these processes where they can automatically identify the part type, generate a pick strategy, and also the path to and from the parts bin. Again, more complex and more costly typically. So you want to know exactly what's included in your automation proposal. As Phil mentioned earlier, what kind of capabilities does your supplier have? Some people do everything turnkey, some sub out different parts of the project. You want to clearly identify what's included in that proposal. And one thing that could be an advantage, are there any tasks that your own people can handle? Sometimes the best training for your own personnel is to help with installation and debug of the system. That can be a real big benefit. Do you really need to automate 100% of your process? I think a lot of projects fail when people try to automate 100%, when maybe 70%, 80% could be successful and have a good return on investment. Sometimes it's important and more cost effective to integrate your skilled labor into the process. Of course, it needs to make sense, but sometimes it does make sense. The 80-20 rule applies. You could spend a lot of time trying to finish the last 20% of your automation when a person could do it quite easily, and you may already have people trained on staff. So again, 100% automation is great, but not always needed. Here's a good example where robot automation is handling the tedious material handling of a part, and then the people are doing the inspection. So these people are obviously highly skilled to inspect these particular cutters. There certainly are vision systems out there and inspection systems that can do inspections, so you have to weigh the cost aspects of both. So again, it can be a highly successful project without being 100% automated. So half the battle with automation projects, just like home projects. Picking the right tools can lower your costs, but also lower your headaches or have less headaches. And your proposed solution should be based on what you need, not what's available. I've seen many times where somebody wants to get rid of a particular robot or automation system just because they need to move it off their inventory, and they force it into an application, and then result could be a very bad implementation and unsuccessful project. So here's an application that is, I'd say, relatively high-end cost too. This particular automation has a robot on AGV that's servicing machine tools. So it has the ability to move autonomously through a facility. It could even be a lights out facility to load tooling into a machine tool. Nice thing about this system, it's very flexible. It can service multiple machine tools. But again, it really depends on your needs and your budget. Collaborative products versus solutions. This has been a hot debate for a long time now. There are many collaborative applications out there that are great and that they work quite well. Whether you're dealing with a collaborative robot or an industrial robot, it really depends on the system to make it safe. On the right there, it seems kind of funny, but we actually have applications where a chainsaw is attached to a robot. So obviously, if it's an industrial robot or a collaborative robot, if a robot has a chainsaw, it's considered quite unsafe. When you're dealing with your automation supplier, you should really make sure that they're going to execute a risk assessment to validate the safety of the system, to understand what's needed to make it safe, and to protect your personnel. And if they're not offering a risk assessment, you probably want to shop to a different supplier. And the question you really need to ask, do you really need people around your automation? A cheap way to protect not only the equipment, but your people is to put fencing. Fencing is a very cheap option. Of course, there are many applications where you need people to work hand in hand with the robot, but I would say the majority of the applications, you really want to keep people out of the environment. Here's a good example of a collaborative application where this collaborative robot is actually portable, so it can be moved from machine to machine. The robot itself is safe. The parts are safe. They're not heavy. They're not sharp. And you can see the cutting process itself is protected by the door that opens and closes on the machine tool. This robot has protection where it has sensors to detect if someone comes in the envelope, and it would limit the torque on the arm if it happens to collide with somebody. You can see there was automation added with an AGV to load, unload the parts. And both of these pieces of automation have built-in sensors, so if somebody gets close, they're going to stop, protect the people. One way to lower your risk is to request a simulation as part of your proposal. Simulation tools are awesome these days. It will help you with not only selecting the right robot or automation piece, it can validate cycle times, it can help you with system design. Making changes in the digital world is pretty cheap. I mean, you're dragging a mouse around. Once you hit the floor, it's very expensive to make changes. So take advantage of the simulation capabilities of your supplier. Here's a good example of a simple pick and place automation for a machine tool. Pick and place in raw material, remove and finished goods, placed on the secondary pallet. And you can see here the cycle time is just under 30 seconds. And with today's tools, I mean, you're going to be within a couple percentage points of the actual cycle time. So in this case, not only was the reach validated, but also the cycle time. A simple change with the gripper. Now we could not only grab the raw material, but we can grab the finished parts with the same gripper. So the process is optimized, and in this case, the robot is not the bottleneck. It's ready to go for the next process. And you can see that the cycle time was reduced to just over 20 seconds. Here's the same simulation, but more of a higher end, a more realistic simulation to show the whole process. So you can look at different views. You can see if there's going to be any potential bottlenecks within your facility, any operator interfaces, any ergonomic issues can all be done offline. And if you're not validating, I'd say 90% plus of the application offline, you're really wasting a good option or a tool that's available to you. It could save you a lot of headaches, could save you cost, and also improve your schedule. And of course, you can show the flow of the product moving in and out of the system. In this case, we're using another AGV to move finished goods out of the system. And the same AGV can be used to bring raw material. So the advantages of controlling a robot from your CNC interface. we have an option called KUKA PLC MX Automation. This is how to control and program your robot from a remote system. So why would you use MX Automation? Well, one of the biggest reasons is you can use your existing PLC and NC programmers. Whatever controls experts you have within house, you can also use to control the robot. So you end up with lower overhead. There's no need to learn a new system. You can simplify your operator interface. Whatever you're using today for your operator interface for your machine tool or your automation, you can use for the robot. A common interface for your end customers, so everybody is already familiar with the system. And again, lower overhead, less training that's required. Simplified controls layout. This means that whatever you're using for your machine tool, your other machinery, or even your peripheral devices can also be used to control the robot. Keep the cost down, improve the schedule. One of the biggest reasons, though, we still have a shortage of robot programmers. Typically, there are more PLC NC programmers available. And to be honest with you, some PLC and NC programmers don't want to learn a new system like a robot. So you can use their existing skills to program a robot and control the robot. So the whole idea of MX Automation is to program, diagnose, interface everything from the robot through the PLC or the NC controls and from a common interface. So in that case, no robot knowledge is really needed by your end customer or from your engineers. If they have experience on the PLC side, NC side, in theory, they're already a robot programmer. All the simple robot commands are done over the PLC NC functions through libraries, or if you want to program with high-level language, C#, C++, Python code is also available. All the robot path planning and all the robot safety is still done within the robot control, but all the programming is done remotely. So the whole concept with MX Automation is you inside your plant, you may have a PLC or an NC control. You can add libraries to that system. We support a variety of brands. One thing to note, the robot is always an automatic external, which means the PLC or the NC has full control of the robot. The PLC libraries are actually independent of the robot type. So depending if you're working on Allen Bradley or Siemens, you can control any of the KUKA robots. So the complete robot portfolio is available. Since you're able to do a lot of the functions remote with an HMI or a non-KUKA pad, smart pad, for example, some customers actually choose to remove our robot pendant and put it in a drawer and maybe only take it out for maintenance purposes. In that case, everything can be done with a remote, a custom display that's remote on your PLC or your NC. Again, you don't have to do anything on the robot side. Everything's done from the PLC or the NC side. So we support all the basic functions to design your robot automation. Jogging and teaching, like I mentioned, can be done from a non-KUKA pendant. You still have the option to use the KUKA pendant if you wanted to. All the standard motions are available. Linear motion, joint motion, circular motion, approximated motion types or blending is available. Triggers for doing switching within the application. Basically, anything you could do within a normal robot program, you have the ability to do from your PLC or your NC controls. Each system can support up to 5 robots from a single PLC or NC controls. And switch-in bases or tools like that is commonly done on the robot side is also available from this interface. You have full access to the robot I/O system. So reading and writing digital outputs, analog inputs and outputs is also available. And again, since you don't need the teach pendant, you can look at all the different messages remotely. You can acknowledge our messages, so all within your HMI. We support all the big brands for PLCs and NC controls. And as I mentioned, some high-level language libraries like C++, C# or Python. All the standard protocols are available, whether it's EtherCAT or Ethernet protocols. The same protocols for safety, like ProfiSafe with Profinet, FSOE with EtherCAT, All the standard protocols are supported. There's a new interface that we've adopted with MX Automation. It's a standard robot command interface. This is mainly driven or pushed by Siemens, but a lot of robot companies and PLC companies have also adopted it. So basically, various robot companies and PLC manufacturers came together to develop the standard. And today we have approximately 115 different functions within the standard. From a functional point of view, it's similar to our standard MX Automation, where you have function blocks within the PLC that it will communicate over Ethernet network or maybe a field bus to control robot motion or get information in or out of the system. So it's based on a client-server system where the server is sitting on the robot side and the client, being the PLC or the NC, would log in to send commands to the robot. I get feedback to and from the system. So as I mentioned, you don't really need to learn how to program the robot. So how would you program a robot without knowing KRL, which is the KUKA robot language? If you're on the KUKA pendant, if you wanted to do some linear motion, for example, you would see an inline form as they show on the screen here. And if you were on the PLC side, you'd have the same functionality, but within a PLC block. So you can generate the same type of motion, same type of options, but within your native PLC. And again, if you were on a high-level language like C#, you'd have different libraries that have the same functions. So you can use your existing programming skills and program the robot just like you would your PLCs or your NC control. Really good example is we have an interface for Heidenheim NC controls. This happens to be their TNC7 control. The standard Heidenheim interface and pendant can be used to control the robot. And whether we're on a small robot system with a small control or a larger robot with our full-size control, everything is supported from the same interface. So the full KUKA portfolio is available. Here's a really good example on the left side. We have an NC machine that's controlled by the Heidenheim CNC control, and it's also controlling the automation, which happens to be a KUKA 6-axis robot. So one common interface for both the NC machine and the robot. So if you looked at the details on the Heidenheim control, if you're looking at the language, within the NC language for controlling the CNC machine and the robot, you'd have the same look and feel. You'd have a common interface for your NC to look at jogging the robot or jogging the machine, looking at diagnostics, messaging. One interface for both machines. We have a similar interface for Siemens controls. On the Siemens side, it's called Run My Robot. On the KUKA side, it's the same MX Automation. It's the same scenario as Heidenheim, so where you can control your CNC machine from the same control as you can control your robot. So one common interface for the operator, a common interface for the teach pendant. The look and feel of what people are familiar with is quite a powerful system. I thank you for your attention today, and we'll open up the floor to questions.
All right, thank you, Ron and Philip. It looks like we have a couple of questions already, but there's still time for you to submit one. You can do that using the Q&A tab at the right of your screen, and we'll do our best to get to it. Okay, first question. Can the KUKA robot controller also work as the cell controller for smaller projects?
You want to take that, Phil?
Yeah, that's more of a technical question. Maybe Ron and I can come at this in a couple of ways, but the quick answer is absolutely. Our robot controller can handle multitasking, if you will. So you can handle basic part feeders, conveyors, certainly examine part presence sensors, directly connect to vision systems, turn on light stacks, indicator stacks. So as long as it's not overly complicated, certainly handle auxiliary axes as well. But Ron, what's your thoughts maybe on more complex applications?
Yeah, you could definitely use it for some cell control. We have the ability to do multitasking or multi-programs running at the same time. I mean, generally, rule of thumb, if you're dealing with a handful of I/O and it's not real-time critical, you can certainly handle it within the robot. But if you're dealing with, dozens or hundreds of I/O points, you really want to integrate a PLC into the system.
Okay. We have someone asking, FANUC controls are out in controlling a KUKA robot, correct?
Yeah, it's kind of almost a trick question, I guess. We can certainly interface to FANUC controls through some of the simple interfaces like with a field bus or maybe digital I/O, but we don't have the same control capability for MX Automation. They actually have a closed system where they have something similar to MX Automation, but it's proprietary for FANUC robots only.
And related to the next question, is this robot controller compatible with FANUC CNCs? Moving on, what type of support does KUKA offer for first-time users?
Yeah, that's a good question, and maybe I'll start with that as well. So when it comes to walking a potential new customer through the purchasing and specification process, we have certainly our first line of defense would be our territory salespeople. They will loop in our sales application engineers to help specify the right robot. Once a project is underway, we offer training at our KUKA facility. If you're an integrator and you become a system partner, that training, the whole catalog of training is offered at no cost. And there's always availability, direct calls to our engineering team to walk you through how to start up, program, interconnect control systems. And maybe with that, I'll pass it off to Ron. Maybe it's your thoughts.
Yeah, I guess I would look at it like this. The training required will really depend on the type of application. Like I highlighted in the webinar, MX Automation, you really don't need to know much on the robot side. So if you already have the PLC or NC controls experience, it's literally one day to pick up the MX Automation side. I mean, to be honest with you, from a robot point of view, like myself, I'd rather program in our language and something I'm familiar with, but I don't know PLCs or I don't know NC controls. I'm certainly not an expert there. If you're going to do everything on the robot side, like Phil mentioned, there's various programs for bringing your people up to speed. So it really depends on how the application is dealt with or the type of application and control system.
All right. Next question. How do I know if a legacy CNC will be able to control a KUKA robot?
Yeah, feel free to reach out to me directly. My contact information is right in the presentation here. Phil and I can both help you out there. I mean, we've been doing NC controls or CNC controls for quite a while, so there's certainly a lot of legacy support. So just reach out to us directly. Let us know what you have.
Yeah, and to that point, Ron, we would need to know what, say, generation the KUKA robot control is. We would need to know what it's potentially communicating with, and then we'll say the level of the software, the operating system software. Just general information.
Okay. This seems to be like a two-part question. So the first part is, what is the maximum distance a KUKA robot can travel on the production floor? And then the next part is, are they all pick and place? Todd, if you want to like ask another question to clarify at all, but
I could try to
yeah, any
tackle
thoughts on those?
Yeah. I mean, maximum distance. I mean, if you're doing a mobile robot system, in theory, it's the distance is your facility and the battery power. If you're talking a robot standalone, we're up to about 4 meters reach. I'm not sure if that was the entire question, Todd. And are they all pick and place? Definitely not. I mean, pick and place is a good example for a robot application, but we do all kinds of other automation, whether it's drilling, filling rivets, composite layup, 3D printing, medical entertainment. I mean, we touch various applications.
And to bridge between a static robot on a floor and a mobile robot, Ron, we have KUKA offers linear rails I don't know what the limit is. 30 meters and more, I believe, is.
Yeah, good point. If you want to go a robot on a linear rail, I've seen them up to 50 meters or 150 feet.
All right. Next question. How does the MX automation compare to using RSI sensor interface for controlling the motion of the robot? Can I update the trajectory of the robot in real time with sensor feedback using MX automation?
Yeah, those interfaces are quite different. Maybe from the outside, they look similar because you're controlling the robot remotely. But RSI is a real-time interface where you're directly controlling the robot. And generally, you're creating the path plan. Or maybe you're using sensor data to superimpose that data on the existing path plan. Where MX automation is really an application that's listening from the PLC to send commands in sort of a non-real time. You can certainly queue up motion with MX automation, but you're not really going to use sensors in real time for feedback. So again, from the outside, they look similar, but in the details, they're quite different. And Casey, if you have an application that you're looking at and trying to decide what option is best, feel free to reach out.
All right. I have one more question here. So if anybody else has anything they want to ask, make sure to get it in ASAP. But this question is, what kind of maintenance do KUKA robots require?
Can we tackle that, Phil?
Yeah, I'll, generally speaking, robots, when it comes to the mechanical unit, similar to an automobile, it has lubrication. KUKA primarily uses oils. So the recommended oil replacement, and Ron, I'm going to declare ignorance on the time frame. I don't know if it's measured in hours. I think it's 8,000 or 10,000 hours between an oil change. And certainly if there's been a mechanical, if there's a crash, we don't want to see robots crash, but if they do, then there's definitely further inspection that needs to be done, looking for smaller payload robots will have belts. So you want to inspect belts to see if there's teeth on the belts that have slipped. And certainly when it's mechanical metal gearbox and such, that would also want to be inspected. And then generally on the robot controller, depending on the environment, there's fans that do cooling. So you would want to do general inspection and replacement of, say, dust covers, and then batteries to back up different control systems and whatnot. Ron, maybe you could speak to that.
Yeah, like Phil said, on the larger robots, we have oil in the gears. You're typically 10 to 20,000 hours for the first oil change. And it really depends on the environment. In a harsh environment, maybe you want to do it more frequent. And those are servo on hours. That's not just idle hours. For some of the small robots, especially like with the harmonic gears, some of those gears are greased with lifetime grease. So there's literally no maintenance. But you always have simple maintenance, like say for the first 100 hours to do an inspection. The internal cable sets are lifetime, so there's no maintenance on those. So generally, it's the biggest maintenance are the oil change.
All right, we got a couple more questions here. Do you offer training for individuals who want to develop personally?
Yeah, a great question. I think that was Devin that had asked it. We have, KUKA has two colleges, one at our headquarters in Shelby Township, Michigan, one based in a college down in South Carolina. Programs for system partners are offered at no cost for end customers and for individuals and for non-system partners. It would be a fee-based training. Everything from 2 or 3 different, actually 4 or 5 different levels of programming, as well as mechanical disassembly and maintenance, and a myriad of other different training classes.
Yeah, there's actually a good KUKA YouTube channel too, if you want to learn some of the basics of robotics and even some of the high-level programming. There's quite a few tutorials on there, and those are free.
Great. One more question here. Can we do simulation work and work visual, or do we need KUKA Sim for that?
Yeah, work visual is more for setup and some simple programming, but simulation is definitely within KUKA Sim. We have a new product being released this year that actually combines both. So in the future, you'll be able to get a free version of a work visual type application that can do simulation.
All right. That's all for today. I want to thank Ron, Philip, and KUKA for making this webinar possible, and thank you to everybody for listening in. You should receive an email with a link to the recording soon. Thank you for your time, and enjoy the rest of your day.
Thank you.
Industrial intelligence.